My name is Marthe Gjerde. I'm a postdoc at HVL, or the Western Norway University of Applied Sciences. And I'm affiliated with the RAW project that you introduced. So in this presentation, I will give an overview of how we collect these sediment cores from a research vessel in wintertime high Arctic Svalbard, and why we collect these sediment cores, why we are interested in them. And I will try and show life on board a scientific cruise and focus on the stepwise process of actually obtaining the sediment cores. How do we proceed when we're trying to collect these cores? And hopefully the resulting data will contribute to enhanced knowledge on past and ongoing environmental change in southern Svalbard, as we find recorded in or reflected in the sediments. So first, I will just show you a picture of the research vessel Kronprins Haakon, which is owned by the Norwegian Polar Institute and run by the Institute of Marine Research and used by these institutions, as well as the Arctic University of Norway. So this was a week-long cruise from the 2nd to 9th of March last year, where I was fortunate enough to participate. We started up and ended up in Longyearbyen, Svalbard. And we were total of 20 scientists on board this particular cruise, which was organized and funded through Polish-Norwegian research cooperation, and was led by Chief Scientist Dr. Jochen Knies at the Geological Survey of Norway and also the University of Tromsø. And there were multiple projects involved in this cruise, including the RAW project and also the Arctic SGD project, where Beata Shimshitsha, I'm not sure if you can see where I'm pointing, but people from the Arctic SGD project were part in coordinating this cruise, and this is how we were able to get our way in on this cruise. So we're very fortunate to have been a part of this cruise. So the main focus during this cruise was to look for gas flares or free gas in the water column and groundwater discharge, and to sample free gas and push cores and look at the biota or the benthic communities associated with these sites of groundwater discharge. So looking at flora and fauna of around these seep sites. So for my part, this cruise was about collecting gravity cores that I needed for the RAW project. So this is just a nice day at the office, I would say. So this is a nice view from the deck towards Hornsund Fjord. So before we start talking about the boat and how we actually collect these cores, I will talk a bit about what sediment cores are and why we're interested in them. So sediment cores are these long tubes of sediment that we collect on the seafloor or the fjord bed, or you can also collect them in lakes using a coring device. So there are several types of coring devices that you can use to collect these cores. You can use piston cores that apply, where you use a weight that you hammer into the sediment. You can use a multi-core, which collects several shorter cores at the same site. And you can also use a gravity core, which is what we used and which is most often used when you're collecting these sediment cores. So from a boat, you deploy a sampling tube, which you can see in the lower part here, with a lead weight on top. And we lower it to the fjord bed, where it probes into the soft sediments by its own shear weight or the gravity. So the age increases with depth, as the layers upon layers have been deposited here on the fjord bed. So the deeper you go, the older the sediments you retrieve are. So this could potentially provide you with sediments from recent deposits or today's deposits until down to millions of years even, but not at these sites. So in Svalbard, in these fjords, we are looking at maximum 20,000 years or so, as the fjords were filled with glaciers who eroded any older material that has been laying there during the ice ages. So we find mostly a couple of thousand years old sediments here. So when you retrieve these cores, you get hopefully very nice layers down core that you can analyze further on. And this image shows an example of these layers that you can find. So when you split the cores, when you've retrieved the core and get it back on a ship and bring it back home to your laboratory or whatever, then you can split the cores and you can have a look at what's inside. You can probably notice that you have some kind of layering there. You see different colors. You can find you have different grain sizes, etc. And all of these are variations that we investigate when we're looking at the marine core. So moving on to what these can actually tell us about climate. Well, sediments are deposited over time at the fjord bed here. And the sediments may be sand, silt, clay, a mixture of all. You have animal remains, plant remains, etc., shells. And all of this form layers, layer upon layer, that reflect different environmental conditions upon deposition at that site. So for example, 200 years ago at this site where you're coring right now, you may have had a whole different situation. You may have had a glacier lying there, or you may have had a lot warmer temperatures. And this will be reflected in the sediments that are being deposited at that site. So these layers, like I mentioned, they vary in color, in particle size, in density, the amount of mineralogic versus organic content, etc. And also we find that different processes have these distinct sedimentary signatures that we can use to identify, well, here we see a layer that can tell us that we've had a glacier that's been eroding into this catchment, or here we can see we have had a volcanic eruption and volcanic ash, or we have different processes have these different sedimentary signatures that we can interpret. So looking at these sediment properties and components, we can reconstruct these past environments and try to understand what happened in the past. And the further down into the sediment we get, the older we get, and the further back in time we can reconstruct what has happened at this site and what has affected the sedimentation here. Yeah, so all of this information that we gather is then applied, and then we puzzle the pieces together, trying to reveal the origin of the sediments, and we try to reconstruct variability that has been here. For example, has there been a glacier advance or retreat reflected in the amount of glacially eroded sediments? Has there been a more permanent sea ice cover? Has there been a lot of icebergs carved into this area that will release drop stones that we see a nice image of here to the right? We see these drop stones, these rocks and pebbles that seem to have been just dropped in between these finer grained layers. And also oxygen isotope records that are preserved in shells of marine organisms that have lived here. can be used to reconstruct temperature. And if we find dust deposits, this can reveal former weather and current patterns. We can also reconstruct biological activity and diversity. We have some species that prefer to live in cooler waters, some prefer to live in warmer waters, and these we can use as a paleothermometer. And the relative abundance of these, as well as species composition, may indicate environmental conditions. So all of these are pieces of puzzle that we look at as detectives, basically, to try to infer what has been going on at this site in the past. So just by looking at the core in the middle part here, we can see, for example, that we have a yellow layer of sediment that was deposited between 9,500 years ago and 4,500 years ago. So that's 5,000 years worth of deposits. And then up to present, which is 4,500 years worth of deposits. That's a lot thicker sediment sequence, so a lot more sediment has been deposited. We've had a higher rate of deposition here, or sediment accumulation, so that also says something about the environment. So there's a lot to be looked at in this course. Okay, so moving on to the ship. So this is Norway's ice class research vessel. It's one of the world's most advanced research vessels. It was built by an Italian shipbuilding group and launched in Italy back in February 2017. It was designed by Rolls-Royce. It cost 1.4 billion Norwegian kroner, and it's quite large. It's 100 times 21 meters. And yeah, it's capable of breaking through ice up to 1 meter thick and accommodates up to 55 persons. And it's equipped with state-of-the-art modern facilities and scientific equipment. We have hydroacoustics, multi-beam sonars, seismics, a moon pool, helicopter deck, remotely operated vehicles. There's space for 20 containers, so plenty of space for storage. So it's a scientific playground, if you will. And yes, so for for the scientists, this is a fantastic ship. We have 15 laboratories available. It's almost one per scientist. Remember, we were 20 scientists on board. 3 container labs, cooling rooms, freezers, a large auditorium, and several types of coring systems. So you can choose the one that fits best with your needs. 5 cranes, and yeah, a bunch of equipment and possibilities to do a lot of work while on the boat. So some of the scientists were working a lot on the labs while we were on this cruise. And me and Siri, my colleague from HVL, we were mostly working outdoors trying to collect these cores. Some scientists were working on mapping the seabed, and some were working on looking at the biology and fauna. So we had different areas of expertise and research going on. So where on earth are we? We are in high Arctic Svalbard in March, so pretty much wintertime still. So we were in Isfjorden area in the mid-western part of Spitsbergen and in Hornsund, the southernmost fjord in Svalbard. And these locations that we aimed at were pre-selected based on former expeditions that were pre-selected locations by the senior researchers and the project leaders. So I was fortunate enough to just join the cruise at a late stage, but I was happy about the sites, which were good for the raw project as well. So we started surveying locations in the inner Isfjorden area before we were heading south towards Hornsund. The aim of the cruise was, like I mentioned, to track groundwater discharge in the fjords and look for gas seeps and free gas or bubbles in the fjords and out on the banks. And this was mainly done by using the ROV, or the remotely operated vehicle, which I will get back to for a great deal of time. So we started in Tempefjorden. It says Superstation 1, and then we continued there in Isfjorden, in innermost Isfjorden, and Superstation 4 is Trygghamna site, which is one of my main sites, and then we went south to Hånsund and Hånsundbanken, which is Superstation 6. Then we went straight south to deploy a mooring, and then further back up to Isfjorden when we finished the cruise. So we had in total 10 locations and 10 main stops in total. So let's move on to the good stuff here. So before we could board, of course, we needed to pack up all of our equipment, and that's a lot of equipment and cases for a lot of scientists for just 1 week worth of cruise. But still, we managed to make it work with a helpful crew deck. And then we could finally settle in. So me and Siri, my colleague, we shared a cabin here, which was really nice. And this was mostly used for sleeping because we were mostly outdoors or around the ship when we had some time off. But very nice facilities. And here Siri shows a mess room where we had food available at all times. So it was quite enjoyable and comfortable here indoors. So this is the largest cruise by far I've ever attended. So that was quite nice to see how nice it was actually here. So we could relax here in the lounge in between shifts. We had movie evenings and we could watch live footage of the ROV at all times when it was deployed. So we could see live video of the seabed, and if there were any biological activity or gas seeps, we could watch it at several sites in the cruise. So let's move over to the actual work that we did. We weren't there for a vacation. So the approximate order of events at all these locations or superstations was the following. We started with a multi-beam survey, and then we continued with inspection by this underwater drone, the remotely operated vehicle. And then this ROV would also collect some smaller, shorter push cores at those sites of interest. And then we would continue to CTD sampling, and finally gravity coring and water sampling in the end. So I will go through all of these and this is a typical station and how it went about at pretty much all sites. So we started out with a multi-beam survey. So it's important before we actually start coring, we can't just release a coring device and hope for the best at any site. We need to map the seabed and the sediments. We need to know the thickness, any disturbances that could be in the deposited layers. The goal here is, of course, to find the most suitable core site. So to generate these high-resolution 3D images of the ocean floor, we used multi-beam sonar systems, and we used acoustics to look at the layering in the sediments. So the point was to avoid any complicating factors that will impact your sedimentary record. So you want to have an optimal coring site where you have these nice long sedimentary sequences relatively undisturbed by any debris flows or any glaciers that have eroded through them or whatever could affect your sedimentary record. And then you get these very nice 3D images of the lake or the fjord bed. Then moving on, there was a ROV inspection. So then the crew deployed this ROV, the Ægir 6000, which was one of the main focus of this cruise, was to use this ROV. So we had 6 ROV operators, or drone pilots on board that were solely there to run this machine alone. So this one can dive down to 6,000 meters, and it's capable of carrying and deploying a variety of equipment and numerous cameras. So the ROV is connected to the ship by cables, and people on board drive it around. And you deploy it through this moon pool, which is an opening in the middle of the ship, and it's actually allows you to perform several scientific tasks while the ship may even be stuck in drift ice, or it's really horrible weather. You can still work from indoors through the moon pool, and you can deploy the ROV from there. So like I said, the main focus for this cruise was to look for gas flares or gas bubbles in the water column and groundwater discharge. And to sample this, you can use push cores, which are these short cores that this ROV can obtain, and also to collect benthic communities that were associated with these sites of groundwater discharge. So for the biologists on board, they would also collect a bunch of living organisms to investigate further for their projects. So this was not part of my project. I was only working on the gravity course, but this is just to show you the possibilities. I will try and start the video now. So now you can see that the ROV is pushing an empty core tube into the surface sediment here. So this is at the depth of around 40 meters, so not very deep. And we see some fish flying or swimming around. And then the nice thing is that as a scientist, you can actually watch this in real time while we're collecting gravity cores or other types of cores. We're doing it blindly, but here you can actually watch it live, and you can tell to the ROV pilot that, okay, I want a core from here, or I want a core from there. This is an interesting site. So that's a great advantage, but it's an expensive equipment and it takes time. But this is just to show you the possibilities of using these underwater drones, which is really nice. And then it collects the cores and brings it back up in these buckets or these cages and transports it back to the ship where scientists began working on the cores immediately. So this is how you can work as a scientist in ocean water, basically without being in the ocean. Yeah, so moving on, after this was done, then CTD was performed. So this particular CTD measures the salinity and temperature distribution in the water column, and then it also can it's used to look at the salinity and temperature at different depths, all the way down to the fjord bed and all the way up to the top of the water column. So this was used for general oceanography on all sites, and then also those interested in aquatic geochemistry were sampling water samples from this simultaneously. And then finally, it was our time to shine. So now I will show you the gravity coring and how we went about. So gravity core consists of a plastic liner. That's this black thing that Bjørn Runar is holding onto here, which we insert into a metal tube called a barrel, which is behind him. So now he's shoving this into the barrel, and we have a heavy weight on top All the way on the other side of it is a heavy lead weight, almost 1,000 kilos. And then finally we mount a core catcher in the end. So this core catcher captures the sediment when we extract it from the fjord bed, so not everything just falls back into the ocean. So this plastic liner was 6 meters long, and this we had to do for each location, a new barrel in a new plastic liner into the steel barrel. So now that we've done this and we have mounted the core catcher, then we are ready to lower the gravity core. And it's important to have warm clothing and waterproof gloves here. That's essential when we're working out on deck, which we were pretty much the entire time because it was quite freezing. It was minus 25 to 30 degrees a lot of the time. So this made it difficult to stay outside for too long periods of time. It was in fact so cold that we needed to run water through the core barrel, which you can see here, to prevent freezing in between the coring operations. We had an incident during the first location where the plastic liner actually froze into the steel barrel, and we had to dismount the entire lead weight of 1,000 kilos, and we spent a couple of hours just trying to release that core liner with the sediments from the steel barrel. So we learned, and we ran water through at all times after that. We also had the possibility to use fuel to heat the deck so we could work outdoors, and this stopped ice from forming on deck, which you can see here. So that's quite nice. It's expensive, but it's very useful, so we don't have to slide around like ice skaters here. Yes, so now we've come this far, and now the deck crew can help us attach the wires and winches and cranes to the lead weight and transport it over the edge, and then we are ready to lower the gravity core. This is how it looks on the left when you're ready to lower it into the water column. So we lowered it from the surface and downwards. That's approximately 1 meters per second until it reached a few meters above the seafloor, and then the core is lowered to the bottom where the weight on top drives the barrel and liner into the sediment. So the gravity itself drives it into the sediment, and we can watch at all times how far above the fjord bed we are. We have these numbers on the right showing us the speed, if it's going up or down, and the weight of the corer. So we know if we have gained sediment or if we have been unsuccessful. So we have plenty of possibilities to monitor this. So this is how it looks when the core enters the surface of the fjord, and now it's ready to take it on deck. Oh, sorry, I don't know if you have any sound there. But here we can see they're still lowering it. It's quite heavy, but we could see some sediment actually. I will restart it so we can actually see some sediment here in the core catcher as well. Just that with the sediment along the steel barrel here shows us that we have been able to penetrate into the sediment. So that's a good sign. So this core is then brought onto the ship, and it's then essential to keep washing it with warm water to prevent the core liner from freezing into the steel core barrel. So here Siri was straight away cleaning the core barrel, and the others are trying desperately to try and get the core liner with the sediments out of the steel barrel before it freezes onto. So all hands were on deck and everyone was helpful trying to keep the temperature somewhat above freezing here. So Siri was really efficient in cleaning these barrels. So all the dirt ended up on her and me, and also on the deck crew, who weren't too happy about this, but still, it was we were successful. So that's the most important part. So here we attached a rope or a pulley system to pull the plastic liner or the core tube out of the steel barrel before it froze. And here we see it's partly outside already. And then we had really happy faces when all ends well. So then we could enter to the left here, indoors, where the moon pool and the hangar was. And you can see in the background the ROV. So then we were able to start working on cutting and sampling and labeling the cores without freezing too much. So that was very good. So after retrieval, the liners were manually cut into sections, and caps are placed at both ends, and the core is stored in a cooling container at 4 degrees. So it's vital to label these sections and keep track of what is up or down, or the entire point of these sediment cores is basically gone if you have no idea what was up and what was down. So it's very important to keep your head straight when you're doing this. Yeah. And then Beata and other scientists on board were also sampling pore water directly from these gravity cores. So they were drilling holes in these cores, sampling directly to look at the pore water and different isotopes here and radioactive decay while underway. While we were sampling and packing our cores, preparing them for shipment back to Norway. So I'll just show you also some nice views from this trip that we had. We were really, really fortunate with the weather and had pretty much very nice, fantastic, cold, but nice weather. So this is from Tempelfjorden, Tunabrean Glacier. And this is in Tempelfjorden. I swear there is a polar bear in here. It's just at a far distance. And here we have a nice view from Hånsund, Gnålodden and Gnålberget. And yeah, the same mountain, but from a different angle. So very, very nice time to be there. So this is the Polish station in Hånsund at the entrance of the fjord. And this majestic mountain in the middle is Hånsundtind, the highest mountain peak here at 1,431 meters above sea level. So you can see that we had magnificent views, and we also had very little or not existent sea ice in March in Svalbard, which normally some decades ago would be covered with sea ice here, but this also allowed us, of course, to have easier access and be able to core here at this time. But it wasn't all glitz and glam and nice scenery, so we have some specific challenges in the Arctic when it comes to fieldwork, and in particular during winter. So like I mentioned, we had some issues with the plastic liners freezing inside the core barrel, which we were able to avoid by leaving water running through the core barrel at all times in between corings. However, we still had some issues with water freezing on board, but thankfully we had a very skilled crew here that helped us, and we were able to make everything work. And we actually ended up with sediment cores from 5 sites here, which was more than we'd hoped for. And these are currently being analyzed now. And hopefully we will produce a reconstruction of the depositional environment here in the glaciated fjords in Trygghamna and in Hånsund, stretching back to 2,000 years if the radiocarbon ages are correct for Trighamna at least. So we can produce relatively long environmental history for this particular site. Yeah, I think that was it for me. And if you're interested in more, please check out the RAW website, where we have many more colleagues working on different aspects here in Svalbard. Thank you.